Hi guys, welcome back. I hope you had a wonderful long weekend and that you're excited for the new week. This week, as you read in the assignment, there's only one assignment. It is worth double credit. And remember, as everything has been happening, you're getting 2 grades. So please make sure that you read the Google Classroom assignment. If you didn't do that, go back. There's little extra credit hints in there. And then you come back over here, take good notes, post your notes, show all of your work, and post that as well. You're getting 2 separate grades, one for the notes, one for the other part. So go back in your notes from last week and find where you wrote this down. If you don't have it, pause the video right now and write this down. Scroll up. Pause the video here, write this down as well. And then pause the video here, write this down. There's one new thing. So if you find your notes from last time and you have all of this, don't rewrite it. Just find this section where it says the probability of 2 events, and we're going to add only if they are independent, okay? And you can even just write it here. So you can put a little note right down here, only when the events are independent. So that's the only time you use this formula. That's a really important thing that we're going to come back to later. So please add that to last week's notes and then just continue from there into this week's notes. Okay, so now we're going to start with conditional probability. So title it, write down all this definition. Conditional probability is the dependence of events is defined by the probability that an event will happen given that some other event first occurred. So that means, for example, what is the probability that I take an umbrella out with me on any given day? Okay, well, it's probably not very likely, right? What is the probability that I take an umbrella given that it is raining? Well, now that probability is going to be affected because these are dependent events. They affect each other. So that's going to be a lot more likely. If it's raining out, there's a very good chance that I'm bringing an umbrella with me. So that's what a conditional probability is. It has that given that idea in it. This is really important, so you want to write down these are the notation for how to use conditional probability. And that means, and make sure to write this as well, the probability that B occurs given that A has already occurred. Okay, this is the formula for it. So important. So you want to put it down, highlight it, do it in color. Okay. And I also showed you a simpler version of that formula right underneath it. Write that as well. Okay, if you need to pause, go for it. I'm going to just scroll down. Okay, so we're going to look at this example of this table right here. So if we're finding the probability of B given A, so that means the probability that B happens given that A already happened. So the first thing I do is I find the probability of A and B. So I go to A and B, and that's 30 out of the total of 128. 30 out of 128 over, and then I find the probability of A. A is all of A out of the total, so 48 out of 128. Okay, I can just divide this now, so just make sure you put parentheses around the top and parentheses around the bottom. So I just do parenthesis 30 over 128, close parenthesis, divided by parenthesis 48 over 128, close parenthesis, and it equals 0.625. Okay, you can also convert the top into a decimal, bottom into a decimal, and divide. I'm going to show you an easier way to think about it, and that's this right here. You're just saying, what is A and B, okay, in the world of A? So you're finding the probability that B happens in this world. So you take your highlighter. You definitely want a highlighter for this. And this is the world you're going to highlight. So everything in the A column, I'm highlighting. That means I'm only looking within this world. So I'm finding what's the probability that B happens within the world of A, so within this yellow world. So that would be the 30, which is the probability of B happening, over the 48, which is the total in this column. And then if I do 30 divided by 48, I still get 0.625. Okay, this is going to be the way that we kind of focus on it here. Write down that conditional probability. You want to look for words like given that or out of. Okay, those are going to be really important. Let's do another example. What's the probability that a student likes drama given that they like sports? first, the way you write it is like this. Make sure you want to put this all in your notes. So if you need to pause it to write it down, do that. I'll tell you what you don't have to write down after. So this is saying I want to find the probability that they like drama, so that's they like drama, given that they like sports. So in the world of sports. So that's what I'm highlighting. So I go to sports and I highlight that whole column. Okay, I'm ignoring all the people who don't like sports. That doesn't matter to me. So this is my total now. I'm saying what's the probability that they like drama? So that's the 35 of them like drama over the total, which is 60. If they just ask for probability, you give the fraction. If they ask you for a decimal, okay, this is 0.583333, and then we're just going to round it to the tenths, hundredths, thousandths place, which is 3 decimals after, and you look at the next number. 3 tells it to stay the same, so it's 0.583. Okay. And that is it for this page. Okay. So just a quick thing about probability, what it is. It is saying, what is the chance that something's going to happen, right? And the scale we're looking at is a 0 means it's impossible. There is no chance it's going to happen, 0 possibility. A 1 means that it's certain. It is absolutely going to happen. So notice anything in between there is going to be a decimal. Probabilities always have to be a decimal between 0 and 1. If something says the probability is 2.5, you know that there's a mistake in there because probability can't be above 1. You can't be more than certain. If something is absolutely going to happen, there can't be anything more than that. So nothing can be above 1 for probability. If it has an even chance of happening, it's 0.5, right? That's like 50%. These can also be written as percentages. This would be 100%, this would be 0%, and this would be 50%, right? Just turning a decimal into a percentage. If it's up here like 4 out of 5 or like 70 or 80%, that's likely. That means there's a good chance it's going to happen. If it's like 1 out of 6, that means it's not very likely. So it could happen, but it's probably not going to happen that often. Let's look at some examples now of how we do conditional probability. So first, if they give us the two-way table, I just have to make sure I have my totals. This one doesn't have its totals, so I'm going to be adding those on. Okay, while I read the problem. So it says in a class of students, the following data summarizes how many students have a cat or a dog. What is the probability that a student who has a dog also has a cat? So here we go. The probability that a student who has a dog also has a cat. So that's saying that we're living in the world of the students who have dogs. So I'm going to go to dog, and I'm going to highlight everything in that. And I forgot to fill in all my totals, so I'm just going to 4 plus 5 is 9, 14 plus 3 is 17, 14 plus 4 is 18, 5 plus 3 is 8, and 18 plus 8 is 26, or 9 plus 17. Okay, so I filled in my totals. Now, because it said the probability of the student who has a dog, so that's in the world of dogs, that they also have a cat. So now I'm going to look and find the cat, which is right there, out of the total. So it's 4 out of 9. And that's it. That's how you find the probability. That's a given probability, a conditional probability. So it's not out of the total of 26, right? It's out of our new total that's in the dogs. Okay, let's look at the next one. The following table represents the highest educational attainment of all residents in a certain town. If a resident who's 40 or older is chosen at random, what's the probability that they've only completed high school? Round your answer to the nearest thousandths. Okay, so I'm going to go back and it says, if a resident who is 40 or older is chosen at random, that means that that's the world I'm living in. So that's what I'm going to be highlighting. Okay. You don't have to write this example down. Then it says, what is the probability that they've only completed high school? So I'm within that, I'm looking at high school only. And that's both of those. Because they've only done high school in this age group and only done high school in this age group. So now all I have to do is combine those together. Because that's all the people who only did high school within the world that I'm talking about, So I added those two numbers and I got 1,836 out of, and then my total of everybody who is 40 or older. So that's these guys who are 40 to 49 and 50 plus, because those are all 40 or older. So I have to add those together, and I get 6,876. Now it said round it to the nearest thousand, so I need a decimal this time. Okay, whenever it says round it, that means you need a decimal. So I divide this and I get 0.2670157. I'm looking at the first three numbers because it says thousands place. And the next number 0 tells us to stay the same. So it's 2.267. Okay. Next example. Notice here they don't give me. So if you, at the beginning they gave you the table, you had to add totals. Then it was a little bit more complicated. Now we have to make our own table. You must make the table for these problems. If you don't make it, you will not get full credit. This season, the probability that the Yankees will win a game is 0.49, and the probability that they score 5 or more runs in a game is 0.62. So before I even keep reading, I'm going to set up my table. So the first thing they said was win a game. So you can win or you can not win. What else is not winning called? Losing. Absolutely. Okay. Total. Then it said you can score 5 or more. 5 or more runs. Okay. And then I guess there'd be less than 5, right? That's the only other option. Runs. Okay. Here in this problem, they were giving us probabilities. So, what would the total be? Well, the total is going to be 1. Because remember that this is all the possible outcomes, right? Every possibility adds up to 1, which is certain. That's everything together. So the first thing it said, the probability that they win a game is 0.49. So I go to win, I go to the total, and I put in 0.49. Then that they score 5 or more is 0.62. So that's the total for 5 or more. The probability that the Yankees win and score 5 or more. So I go to win and 5 or more, and that's 0.4. Now I'm going to fill in all the others. So remember, we just do that by subtracting the total minus whatever's above it. So 1 minus 0.62 is 0.38, because these add up to equal to the total. 0.49 plus this is going to equal to 1. So I just do 1 minus 0.49, 0.51. 0.49 minus 0.4, 0.09. 0.38 minus 0.09, sorry, is 0.29. And 0.51 minus 0.29 is 0.22. Or you could have done 0.62 minus 0.4. Okay, so now we filled it all in. It says, what is the probability that the Yankees will win when they score fewer than 5 runs? So when they score fewer than 5 runs is the world we're living in. So we're going to go to fewer than 5 runs, that's less than 5, and that's what I'm highlighting, because that's the world I'm living in. It asked me for the probability that they win, so I'm looking for win within that. So here's the win out of this is my total. So it's 0.09 out of 0.38. And then I'm going to divide. And I get 0.236842. And again, I want to circle my first 3 numbers. And the next number tells it what to do. 8 tells it to go up, so 236 goes up to 237. So it's 0.237. Okay, and last example. At LaGuardia Airport for a certain nightly flight, the probability that it rains is 0.16, and the probability that the flight will be delayed is 0.19. So I'm going to set up my table and start talking about it. So we've got that it can rain, and then the other option is that it doesn't rain. You wouldn't write like snow because there's other things besides for snow that it could be, right? It could be no rain at all. It could be good sunny weather. It could be hail. It could be other kinds of a tornado, right? So it's either rain or not rain. Then it says that the flight will be delayed. Well, what's the opposite of delayed? Not delayed or on time. Okay. Now, if you just think about this makes a lot of sense because the probability that a flight is going to be delayed if it's raining, it's probably going to be much higher than if it's not raining or just in general, right? So we're going to take a look at that. That's conditional probability. So it's saying what's the probability that this happens given that that already happened. If it's on any given day, the probability that a flight's delayed maybe is like 20% or something. But on rainy days, I'm sure it goes up to like 60 or 70%. So let's take a look at our numbers. Since they're giving us probabilities, I put the 1 here. Always put that 1 there. The probability that it rains is 0.16. So I go to rain total, 0.16. Delayed is 0.19. Delayed total, 0.19. And the probability that it will not rain and the flight will leave on time. So make sure you go to the right one. Not rain and leave on time, and that meets right here in 0.7. And now I fill everything else in just by doing the subtraction. So 1 minus 0.19 is 0.81. 1 minus 0.16 is 0.84. 0.84 minus 0.7 is 0.14. 0.19 minus 0.14 is 0.05. And 0.81 minus 0.7 is 0.11. Okay. What's the probability that the flight would be delayed when it is raining? So remember that when it is raining is the world that we're living in. So I highlight the rain, and then we say the probability that it's going to be delayed. So I look at that number. So it's 0.05 over the total in what I highlighted, 0.16. And I get 0.3125. And again, the 5 tells it to go up, so it's 0.313. And that's how we think about conditional probability. Okay, so those are all the practice problems we're going to do. You have to make sure to show all of your work. For any question where they don't give you the table, you have to create your own. If you don't have those written down, you cannot get full credit for this. Take your time. This is your only assignment you have this week, and have fun. Bye.